Hello everyone, this is Terry Erzman. I'm the Chief Marketing Officer for Percona. I would like to welcome everybody to today's webinar. Before we get started, I'd like to make sure everyone can hear me all right. If you can hear me, please raise your hand in the GoToWebinar control panel. Okay, I see lots of hands raised. Thanks everyone. Very good. We will be making a recording of today's webinar, and we'll send a link to the recording as well as to a copy of the slides within the next 24 hours. You will receive that via email. If you have any questions during today's webinar, please submit those through the questions panel in the GoToWebinar control panel, and we'll answer as many of those as we can at the end. And if there's any we don't get to, Fernando will address those later in a blog post. With that, I would like to welcome Fernando Ipar, who is a senior consultant with Percona, and his topic today is 10 Percona Toolkit tools every MySQL DBA should know about. Fernando?
Hello, Terry. Thank you for the introduction. Okay, thanks everyone for joining today's webinar. I hope you find good value in it. And as Terry was saying, I'm going to be reviewing 10 of Percona Toolkit tools that I think every MySQL DBA should know about. Terry already introduced me, right, so I'll just go ahead and skip this slide. But there's my email there, so other than the blog post that Terry mentioned that I will do as a follow-up with any questions I cannot address today, feel free to just write me an email directly if you have any follow-up things to discuss about today's talk. Now on to the presentation. This is all about introductory level to the tools. I'm not going to be doing any in-depth discussion of a specific tool. I've selected the 10 for this list based on frequency of use. That is my use as a consultant. And all of them have use cases based on actual customer cases that I've been working on recently. And I've classified the presentation by category. And this is some tools that do replication management, others for performance optimizations, some that will help you manage MySQL operations, and then a couple of tools that are very good for root cause analysis when there's problems. Like Terry said at the beginning, and you just can type your questions into the GoToMeeting question form, and Terry will read them to me at the end, and I'll address them there or by the blog post after the presentation is done. Now, a little bit about Percona Toolkit. I expect a lot of people already are familiar with it, but it is, every tool in the toolkit is actually based on actual customer problems. I mean, some Percona customer went through some issue, and over the course of resolving their issue, we saw that it was good to create a tool to handle that, and so we did. This has roots on a previous toolkit that was called MapKit. Some people are still using that. I would recommend transitioning to the new one if it's possible for you, because the market is no longer updated. But this is where it has its roots. It has an extensive test coverage. If you guys go to Launchpad and look at the source code, there are many test cases for most of the tools. That's one of the reasons why I think you should prefer, as a DBA, using something from Percona Toolkit instead of cooking your own solution, because possibly, you know, we just because of the fact that this is used daily in our work by many consultants and support engineers, we have seen edge cases that may apply to you in the future, but maybe not now. So we have been through that, so that you don't have to. It works with every version of MySQL since 5.0. Some of the tools work on 5.1. but not all of them. And I think mostly the PT upgrade tool, which I will be discussing briefly today, does handle 4.1. It has a very good community built around it from the days of MapKit, and now in Percona Toolkit 2, you can get help from either the Percona forums, you can go on Freenode to the Percona channel, and also it is covered by support services if you need, you know, professional support to use them. Now, before we begin, let me spend a few minutes discussing data source names. If any of you are PER programmers, you will be familiar with this. I'm not, so this is one of the things that I had to learn how to handle when working with the tool. This includes all of today's tools other than pt-stalk and pt-sif. That's because those two are based on Shell. The others are all written in Perl. Now, in a nutshell, this is the DSN is a comma separated key value list. There's an example there. You can see that that one would connect to MySQL on localhost using root and that secret password. And for any tools that use multiple hosts, for example, the replication tools, the DSN inherits from others. So for example, if a tool has to connect to a master and then to a slave, you specify the DSN for the master, and for the slave it will change the host name, but will use the other values. You can change that. I will refer you to the manual, but in a big picture view is that you can create a table in MySQL, put in all the credentials info, and tell the tool to use that table. So it's not impossible to use with different credentials. But I found myself, and I recommend to you, your life will be much easier if you just keep the access credentials consistent across all hosts. This is especially true if you have a lot of hosts. There's a URL there with the full story about the DSNs, but with these things, we are ready to move on with today's talk. Now, before running any of the tools, I suggest that you read the manual carefully. The manual is available both online if you install from the packages, that is via man, or you can read it on the web. It's generated from the same place. Test, run a test case of what you want to do on some non-production server, and have a tested backup available in case anything goes wrong. I put the emphasis in both tested and backup there because a lot of people have backups, but they never really test them, and that's only half a backup. So let's start with replication management tools now. pt-table-checksum is by far the most widely used tool from the toolkit in terms of replication, and what it does, it can help you verify if a master and its replicas have a consistent copy of the data set. That is, if they actually have the same data. Now, there are many reasons why a replica may not be consistent with the master in MySQL's world. One, and I think the most common, the vast majority of emergency cases that I've worked on with customers in which replication was broken, it was due to somebody writing directly to a slave. It happens more often than you would expect. If you're using statement-based replication, there's a myriad of things that can make it fail. And actually, down there a list in the manual, there's a page called Features and Issues that has 36 subsections. And I'll let you go there and judge by yourself which of those are features and which are issues. I'll tell you that most of them are issues. You can have bad coordinates after a server crash. This is, a slave that goes down for whatever reason, bad power, a bug in the server. And when it comes back, because in stock MySQL and in old versions too, the coordinates for the slave are not kept in sync with what's in memory. It happens that the slave comes back in the past. And so that can also cause data differences. And well, I'll say that you're recent here. Whatever else that you may have come across, it's very normal for MySQL replication to end up, with different data between master and slave. In fact, it's so normal that the tool is based on that. So how does it work? It says here, use statement-based replication. The same thing that I warned you here that can cause problem is what the tool uses. Precisely because given certain cases, statement-based replication can give a different result in master and the slave. And the tool uses that to its advantage. It only changes this for its own session, so it has no impact on your application. If you guys are using row-based replication and you need that for your code, it's perfectly safe to run pt-table-checksum, and it will have no impact in your application. And so what it does is once it changes its session, the being log format to statement, it runs checksum queries against the master. These queries actually write data, but only to a specific table that you can put. By default, that it is now the Percona.checksum table, but you can change it to whatever you want. And this is the only table that the tool writes to, so it doesn't change any of your data. When the queries replicate to the slaves, since it's using statement-based replication, they will be run again. And in this case, if there is a difference in data, the checksum will be different, and you will see it in the results. So as you can see, the tool makes use of the fact that statement-based replication is unreliable to monitor MySQL replication on its own. So the typical test scenario, for example, let's assume we have a master server called A and replicates B and C. We want to make sure that B and C have the same data as A. We just run pt-table-checksum. -- replicate the Percona.checksums. That's the default table that I talked in the previous slides, but you can put whatever you want here. And the data source name for the master. In this case, I'm assuming I have, a myCNF file properly configured for my user, so I just put the host name. And yes, it's that simple. Just that one command will go and run the checksum and let it replicate to all replicas. It will then connect to the replicas, each and every one of them, and tell you if it found any differences. There are some things to consider, though. If you have a difference in schema between master and replicas, it will break replication. So, for example, if a table is on the master that is missing on a slave, this will break the flow of replication. The same can happen if some column is missing, or some data type is different potentially. So, while the tool is very safe, it says there too, it has a self-throttle mechanism based on slave lag. So it will stop running if lag goes beyond a certain threshold. I would not recommend to leave this running unattended until you feel comfortable with it. Certainly, if you run some schema migrations recently, anything that you think that could have left you in the state in which you don't have the same exact schema in master and slave, I would not run this unattended because you may end up with broken replication. Now, if pt-table-checksum gives you the bad news, pt-table-sync is there to help you. This tool uses the output from the previous one, basically what's written to that Percona.checksums table. It finds the chunks that were identified as having different data between master and slave, and it syncs them, basically. I forgot to mention here, pt-table-checksum works with a chunking system, so it doesn't checksum a full table at once. That's another reason why it's very safe to run this in production. It detects the chunk size on its own on the run based on the impact it has on load, both on the master and on replica lag. So, for example, if you have a 300 gigabyte table, it may end up doing chunks of 1,000 rows, 2,000 rows, whatever it thinks it's okay to keep a good level of load on the master server and a replica lag under control. And you don't have to do anything about it. You can change it. You can change the thresholds. But out of the box, with the command that I'm putting there, it just works pretty fine and it's reliable. So back to table sync. The scenario again, you have master A, replicas B and C, and you ran pt-table-checksum, and it turned out that you had different data on C. So you run pt-table-sync, the same argument as for the checksum, -- replicate with the table. And first, I would recommend you run it with -- print. You notice that at the end, I'm connected to the master. This is because if you recall the reasons that I listed as replication going out of sync, writing to replicas is the #1 cause. So this tool only writes to the master. It changes data and it fixes the slave by writing to the master. The type of queries that it does, which are insert, ignore, or replace into, are queries that if the data already exists in the master, it's just it's not going to do any harm. And if it doesn't exist in the slave, it's going to get out of there. And the same with deletes. If a slave has extra information, a delete on the master will have no effect, but it will propagate down the hierarchy and it will fix the slave. So the tool always connects to and writes to a master. And the -- print option, what it does, it tells the tool to only print the queries that it would run, but not do anything else. Now, if you feel happy with the results, if they make sense based on your knowledge of the data, and this is something that you alone can tell, then you can add -- execute, or you can just remove the print and put execute in place. This will actually connect to the master, run the queries, and will eventually get your data back in sync. Here's the little workflow of the whole situation. Let's assume we start with replication in status unknown, and by this I basically mean one of the threads is stopped for some kind of error, or maybe replication is running, but you still don't know if it's okay, so you want to run a checksum. So you run pt-table-checksum. If the result's okay, well then we're all happy. If it's not, there has to be a unique key for every table involved for pt-table-sync to work. Otherwise, you can do it, but I would not recommend it. I think it's easier and safer to just do a manual sync in that case. And this is, one of the many good reasons that there are to enforce the fact that every table should have a unique key. It doesn't have to be a primary key for pt-table sync. Just any unique index will help. pt-slave delay. This tool was written to intentionally keep a slave behind in time. This is so like a full month's backup. I don't know how many of you guys read this comic strip, but this one about Boppet tables is a good example of why just replication is not a good substitute for a backup. If somebody goes and accidentally or intentionally runs a drop table on your master, if you have replication, it will go and happily replicate to the slave, and you will be losing the table on both or all your servers. So obviously a backup will help here, but having a delayed replica could help too. Now what pt-slave delay does is it uses the feature from MySQL replications start slave until, and so it basically stops and starts the slave thread on the delayed slave and keeps it approximately, it's not exact, at the amount of delay that you're specifying. So for example, you could, in the previous case, somebody does some SQL injection trick on you and drops a table. If you have the 2-hour delay slave, if you notice in production right away that a table is missing, you can go to this slave, stop replication, start it right up until the point on the master where the table is dropped, let it replicate, and when that point reaches, you can just flip nodes and go on with your life with no impact on that lost table. And finally, for the replication tools, I would like to review pt-slave restart. In case of, again, replication is stopped for an error, this basically just skips replication errors. It does a few other things. For example, if replication was stopped because a relay log was corrupt, which is very common in MySQL, I believe 5.6 includes some better checks for that, some checksums for the binary logs and the relay logs. Right now, on the currently GA versions, that is not the case. And so it can happen that over the wire, some bit gets flipped and the relay log is corrupted, and that will break replication. This tool, if that's the case, it will do a change master to command, fetch the relay log again, and start everything again. This is a last resort type of tool. I would not recommend running this on a server as normal part of your daily operations. I have seen on a lot of online forums people advising to use skip errors on MySQL configuration like a great way to keep replication always running, and that is a death trap. I mean, definitely it will keep my replication running, as in your nagios checks will always show both thread running and probably no lag or whatever, but you're just ignoring the truth. You want to stop on an error. And so this used only when you know what you're doing, you know that you have a problem and you're okay with it and you still want to move on. Usage is very simple. You just pass on to it the DSN to the slave you want to restart, and the tool will print to standard output the bin log name and the position in which it had to skip an event. And it will do it for as many events as it has to skip or refetch, whatever. And here's another diagram for this tool. If you have broken replication, the first thing that I recommend is having an expert in-house, whatever, assess the situation and before moving on. Before you do, a manual skip counter, nothing. Just take a look at this, try to understand from your application's point of view, why did data end up this way, what did it break replication. Now, once you move to that step, if you really need the slave online, no matter what, and by no matter what I mean, even if it has bad data, then you can use pt-slave restart right away. It will start skipping errors, as many of them as there are, and get replication working. If you don't, well, you can go ahead and do pt-table-checksum and pt-table-sync. If you use pt-slave restart, obviously the flow there marks it. I do recommend to use pt-table-checksum too. One thing I did not mention, but after running the checksum and the sync process, I recommend running another checksum. This is due to the way replication works. It does not have to do with the tools themselves, but with the fact that MySQL replication being single-threaded, it has to serialize any changes, and it doesn't lock tables or anything while it runs. So it may happen that you're running checksum, you find some differences, and as the sync is fixing them, other changes that you have going on concurrently on the server will once again make your data drift away from one server to the other. So as a rule of thumb, always after I use pt-table sync or after a manually fixed replication, I go on and run another checksum. An important advice, if you're using statement-based replication, skipping errors, that is using, for example, pt-start, can usually make a bad situation worse. This is because, unlike, row-based is pretty safe. In general, with row-based replication, the reasons that I've seen for replication to break is somebody, using the wrong coordinates or maybe a crash. But otherwise, it's pretty reliable because it actually changes copies and changes data from one server to the other. Now, with statement-based, it actually runs the statements again. And even though, a lot of work has been going on into this since probably, I don't know, 1999, 2000. My memory is not good on that. I mean, on used edge cases and all that, it's still, conceptually, just replaying statements, it's not very reliable. And for example, if you have a table with salaries, and somehow, because somebody changed a slave directly or whatever, you have one salary value different for one employee in a slave than in a replica. If you just keep skipping errors, the calculations, whatever that you do, when they run on the master, they will give one value. When you run them on the slave, they will give another one, and they will continue to propagate this. So what I'm trying to say is that data drift tends to propagate if you don't keep it under control. So skipping errors is always, a last resort kind of thing. If you can afford some downtime, taking your server away, running with lower capacity, by all means do it, and do not have a slave online that have bad data. And pt-habit is the actual last tool on replication. This reliably measures replication lag. You know that MySQL provides a value from show slave status that's called seconds behind master, and it can be used kind of like to gauge replication. It's as reliable as measuring wind speed by using sticking your wet finger on the wind. So, but it gives you some idea of direction at least. It works. This pt-habit, the tool, is much more reliable. It actually measures how far behind in time a slave is. It can work with the Percona monitoring plugins. There's a URL there in case you didn't know about them. Basically, it's some cacti templates and some nagios monitoring plugins that we've developed for any MySQL version, including Percona server. Here are some graphs, a couple of pairs to compare. On the top is what seconds behind master gives you, and on the bottom is what pt-habit gives you for the same workload in two cases. So if you see on the left, what happened here is that there was a series of large statements in replication, and there was a flush tables with read lock run on the slave. And you can see the replica as measured by seconds behind master. It spikes from 0 to about 20 right away. At the end of the flush table, it goes back to 0, and then it has another spike. This is very normal. I mean, it's very normal for me to see seconds behind master going back and forth between 0 and arbitrarily large number when a slave is catching up with some specifically heavy queries. You can see in the bottom that pt-habit actually, more reliably reports the delay. It's always growing until the slave catches up and it goes back to 0. And on the right is a similar situation. We have two peaks in both cases, but you can see that the Harvard graph is more, the slope is different, and that's also because there is an extra graph at the first there. It says statement there because the second one, the examples on the right, were used by workload using statement bin log format. If you're using statement bin log format and you're replicating very large queries, like an update that takes a lot of time for calculations, even if it only changes a few rows, seconds behind master is even more unreliable on the slave, because basically due to replication build single threaded, when that very large query starts running, seconds behind master is a timer, starts growing 1 second at a time, and when that statement finishes, it goes back to the timestamp of the next query. Usually this means it goes back to 0. Then it's going to spike again. Again, pt-habit does not have that problem. It actually measures the time in the difference time. And how it works is on the master, you run it, pt-habit. You need to tell it a database to connect to, and it can actually create a table. This command invocation I'm using here uses -- create table to automatically create a table. And you must use -- update on the master. And what this will do, it will update a record on the master with the current timestamp. This works even if you have many levels of masters and slaves, because the table also has server ID and it is actually the key. So at any given time, you can run pt-hybrid with -- update from many servers, and it will only update the row with its own server ID. So it can be used on a multi-level hierarchy, and it will still be reliable. Now, from nagios, or your system of monitoring of preference, you just need to use -- check instead, and obviously ask it to connect to the replicant, and it will monitor the difference and tell you, and this is reliable. This is, seconds behind master, going back to it, is a measure of the difference between the current timestamp and the timestamp from when the event currently being executed in the slave was executed in the master. In this case, pt-hybrid, what it does is a difference between current timestamp again and the timestamp as it is on that table, and that was written by the master. So it actually measures in seconds, and it actually has sub-second reliability, the difference in time, how far behind the slave is. Now let's move on to some performance optimization tools. pt-query digest, I think it's the #1 tool in the consultant's toolkit. What it does is analyzes MySQL queries from logs. Typically this log query log, but you can do TCP dump captures, you can do the general log, and it helps you find optimization opportunities and prevent scalability bottlenecks by finding a query that maybe now, given your workload, is not too bad, but if you get an increase in concurrency, for example, it can get you into problems. Now, the use is very simple, just pt-query digest and the log. It automatically detects the log type, so you don't have to be telling it what you're feeding it. If you use a bin log, you just need to use MySQL bin log to transform it to a text file, and then it will read it just fine. If you want to use TCP dump, for example, because you're on some old MySQL version that does not support 0 as a value for long query time, you can just go to the manual page, and it will tell you the flags that you need to put to TCP dump for pt-query digest to work with it. And here's an example of the result of the capture. This is the summary part of the screen. You can see on the bottom half, there's a ranking of the top queries by default by response time, aggregated response time. You can see the red square there. And you can notice that in this case, that's why I said here, discover optimization opportunities. The only business, quote-unquote, query in this capture, it was a test capture, but the only actual query that the application will be running is taking less than 9% of total execution time. Yet the top two queries, 54% one, almost 30% the other one, have nothing to do with the business, are just artifacts of the way the application is using MySQL in this case. So we mean that pt-query digest help you give some good guidance to your optimization efforts, because even if you have a slow query here, that select test query is actually bad, and you have users complaining about response time, that you need to work on it. But even if you were to optimize it, say, tenfold, you will only be able to optimize your overall, workload by 8.7%, because that's as much of the time as it was used by that query. So that's why you need to use a tool like this to sort your workload and find what you really need to work on. The item, which in this case is showing select test for the business query, is in summarized format. What it does is it starts with the type of query, so you will see there either select, insert, delete, any of that, and then it will show the tables in use. So in this case, select test does not mean that this was the query, but it means that this is a select from the table called test. If you have a multi-table join, you would see select, and then every single table name listed there right after it. Here's the detail for query number 1. going back here, this is the query that takes 54% of execution time during this capture. Well, you can see there it's basically connector J that by default is very, very verbose. You can see some interesting here things for every query. For example, a response time distribution. That's the histogram with the hash marks over there. You can see how much time was spent waiting for logs, executing, how many rows it examined. The amount of information that you can see there will depend on the version of the server that you're using. For example, this is very good to work with Percona server and the extended slow query log. You get a lot more information here. But with any version of MySQL that's supported, you will still be able to see the basic stats, meaning response time and total aggregation. In this case, the 54% of total response time. You can find that regardless of what version you're using. The only completely reliable way to do this is with a slow query log, though. In TCP dump, you can risk due to packet loss, you can end up having some skewed statistics. So if at all possible, I would recommend using the tool with captures done with the slow query log. The tool supports filtering. It's, like I said at the start, it's written in Perl, and so the filters are any kind of Perl script. And here's a very simple example in which we are only going to process queries that have the user's string. The filter acts before any other processing. This means that if you, for example, I use it a lot when I have a very large log and I only care about specific time frame. For example, I have a slow query log from a server that has like a month of data, and I only want to know about how queries were distributed in the last hour because there was some performance problem in the last hour. But that you can use a filter and filter by events and timestamp. If you go to the manual page for pt-query digest, there is a section detailing all the fields for this event variable, which is what you can use for filtering. It also has a very interesting feature called query reviews, which basically means you can set up pt-query digest and have it run periodically, every day, whatever. I have most of my customers, the customers that I work with in Percona, are doing this every day. And you can ask it to write every single type of query to the review table. Now let me go back a little bit here. When I say every single type of query, if you look again at the ranking in the bottom half of the screen, you will notice that there is a query ID field, and that thinks this is the fingerprint of the query. And what pt-query digest does, and a few other Percona Toolkit tools do the same, is it abstracts away the query to its basic elements, basically eliminating anything that is like parameters. So for example, select star from test where ID equals 4 and where ID equals 7 would be the same query for this, because usually for performance implications they are the same query. And so if we go back here, for every one of those fingerprints, they get written to the review tables. And there's a link there to a project called Anemometer that makes a good use for this feature. It wraps it into a web UI, and I think it's a very nice project. And the review table basically adds a couple of fields. If the reviewed by field is not null, then pt-query digest will never show you that query again unless you use -- report all when running it. So typically in my workload, what I use it for, like I said, I run pt-query digest every day for some customers. It gets written to every single fingerprint goes to the review table, and then me, either myself or some member from the development team of the customer will go through the review table, look at the queries, and if, for example, an internal ticket is created for somebody to optimize it, fix it, or change it, then we can change the review by value, and we don't really care about it again. We know it's bad, somebody's working on it, and I don't want to see it on the reports again. And that's basically the goal of the review feature. Let's now discuss some operations tools. The oldest of the operational tools from the toolkit, and another one that I use too often and probably should be often a lot, is pt-upgrade. And basically what it does, it takes a list of queries and it runs it against a set of servers, comparing response time, errors, warnings, and and results. So it's a very good part of a proper, safe upgrade testing. For example, suppose you want to go from 5.1 to 5.5. As a normal part of the process, what I do is ask the customer for what a good representative time of the day is for capturing traffic. Capture traffic, then I can process it with pt query digest to get just the representative queries, the fingerprinting thing that I talked about earlier, and that would give me a list of queries, a unique list of queries that we're seeing on the server at the time of the traffic. I can then feed that to pt upgrade and ask it to connect to a 5.1 server that should be configured just the same as production, and to a 5.5 server that should be configured as we expect it to be after the upgrade. And if there's any difference, like I said, result sets, response time, errors or warnings, the tool will tell it to me. And this is especially important to catch early anything like an incompatible change. MySQL over time, it gets more and more formal or serious, should I say, in its SQL. It's famous from the early days from managing things like invalid days. You can insert into a MySQL table days like the 4th or 7th of February, things like that. And so over time, things get fixed and some things get more strict. And it's better to catch this, relaxed during the upgrade preparation phase instead of, doing a hot upgrade and finding out because suddenly parts of your application stop working. This is what we have a blog post about it from Peter from a couple of years ago, but it's still relevant, comparing, the two upgrade styles, the reckless style, which is just going in there and swapping the versions and hoping that everything will go fine, and then the, the safe upgrade. pt upgrade is part of the safe upgrade path. Here's a query example. Like I said, you just pass it a list of queries and 2 or more hosts to connect to, and it will run the queries against each host and will tell you the results. Here's an example from our report. I have highlighted the differences. In this case, you can see that the difference is in query response time. And it's actually, an interesting difference. Another more recent but equally useful tool for the operations group is pt-online-schema-change. And this tool was designed to minimize the impact of altering tables. I believe there are many versions from this idea around in the web. I believe that we got the first inspiration from this from a tool from Facebook that is also public. And basically what it does, it creates a table that has the structure that you want to have. I mean, for example, alter table, add a new column. Well, it creates a table that is exactly the same as the existing one, plus that one new column. Then it creates some triggers to copy data to the new table as it is being inserted, to the original one. And in the background, it starts copying data too. When it's done, it just swaps the table with a rename, and basically that's the only, log time that you have. So it really minimizes the log time for an alter table. This is assuming that you do it on a single server. A lot of people are still using multi-master techniques for these things, and that is okay. But not every change can be done on a multi-master environment, at least not right now, or not with every form of replication. For example, changing the column's data type or removing a column does not work well with row-based replication. There's a warning here about being careful with foreign keys. The tool does work with them. It works fine. I've used it in production. But you need to read the manual first because some assumptions are made and you need to specify in which way you want the keys to be handled. And here's an example. I've highlighted the important part basically to, you can see that this is just the standard alter table syntax. So what you pass to -- alter eventually makes it into an alter table SQL command. And the tool is self-throttling too, like most of the Percona Toolkit tools that can have some impact on a server have means to control themselves. In this case, it's also based on load and slave lag. So if you have, replication slaves, you can use the tool to do an alter table on the master, and it will be pretty safe, and it will keep the slaves in line. If the slaves lag either because of the tool running or because you have a change in workload, whatever, it's going to hold off for time. So it's relatively safe. I have used it a few times, and I know folks from Percona support use it quite often to do this. Here's an example from the output. You can read in it basically the most important part. It's how it created triggers, it copies the data, it says about dropping the triggers in the end, and basically just details on how it works. There is a test mode that you can use it. It's not a complete test, but what it does, it will create the table as it is in the end, and I believe it will also create the triggers, but it will not do any other changes or anything like that. And you can also ask it to not drop the temporary table at the end too, as part of your tests. Finally, let me go through the root cause analysis tools. pt-stalk is the star of the toolkit in that regard. It's very useful to diagnose hard-to-catch problems. For example, random stalls. This is something that we face a lot as consultants, especially in emergency services. And what used to happen in the past is that a customer, would approach us saying, sometimes, for apparently no good reason, the whole server freezes, and I don't know what's going on, and then it goes back to normal. And of course, that usually doesn't happen when a consultant is around to take a look. And so this tool was written with the idea of monitoring a MySQL server, waiting for a certain condition, and when the condition is met, it triggers a data capturing processes that gather a lot of information that should be useful for an expert to review and get an idea or maybe even resolve whatever problem is underlying there. I'm going to give you some examples of how to invoke it. In this case, for example, that test function, I'm telling pt-stalk to watch the output from show process list. The function option supports 3 variables. You can double check the manual, but I think my memory is good on this. It's either process list, either show global status, or a function that we'll see in a later example. In this case, the variable is state, and if there are more than 10 threads in process list which are in state statistics, I want pt-stalk to trigger a capture. In this other example, if there are more than 155 threads that are sleeping in process list, I want to trigger a capture. Notice the difference in use of cycles. The cycles means that the condition must be met for at least that many consecutive checks. By default, this is 5. And since by default the sleep time is 1 second, it means that whatever condition you put has to happen for 5 consecutive seconds for pt-stalk to trigger. This specific example, I use it a lot on customers that have connection pooling, typically Rails and Java applications, where you will have as many as thousands of connections open, but only a few are working at a time. And we want to know if there's a leak somewhere, either the pool has a problem, somebody's connecting directly, but the number of sleeping connections should be pretty much steady. If anything, it should decrease when there is load because the connections are no longer sleeping, but it shouldn't increase. And so this will help you catch things like that. This one is just specifies the threshold, and this means that I'm not setting any variable or anything, and so it uses the defaults. The default for pt-stalk is to monitor show global status and look at the value from threads running. So in this case, pt-stalk will trigger if there are more than 40 threads running for more than 6 consecutive seconds. Remember, threads running is not threads connected from process list. So this is a very good measure. Threads connected is pretty much useless in most cases. Like I was mentioning, the pool-in example, you always have like 3,000, 5,000 connections open. Doesn't change a lot. But threads running does change. It is the actual workload that the server is doing right now. And you guys know that you have a normal value for your application, be it 40, 50, 10. Whatever. If you have cacti graphs, and if you don't, then you should. And I refer you back to the slide where I had the Percona monitoring plugins. I recommend you have graphs, and you can know pretty easily, how your trends are and how many threads running you have at any given time. And this is the other promise, using a custom function. In this case, if to dash function you pass in something other than process list or status, it assumes that it's a file name. It doesn't have to end on sh. and it will go and look for that file on disk, and it will load a function called trg_plugin that the file should provide. And the only thing required out of this function is that it outputs a number, and then this number will be compared to -- threshold, and if it matches, it will trigger a capture. So for example, I have used it in the past to trigger captures when load average goes beyond a certain level. This is also very useful if you don't want to monitor MySQL. pt-stalk is a pretty cool script, and it's obviously very focused on MySQL. But for example, I mean, we do full stack consulting, and I once had to troubleshoot some Cassandra memory leaks, and in this case, I just edited the file as a simple bash script, and it's pretty much readable. I just commented out the MySQL specific captures. I added a couple of JVM captures, I believe, JMap and JStack, and I used a custom function for the check, measuring load average, and it worked pretty cool. It's a very good option. So you can use it to monitor basically whatever you want by just changing a very few lines of code and writing your own plugin. And I would recommend doing this instead of writing your own way, because pt-stalk has a lot of things already built in. For example, it will not do a capture if there is less than a certain amount of user-specified free space available on disk. So it will never happen to you that by trying to monitor MySQL, it will bring it down by filling the disk and things like that. It also has, it slips for a default of 600 seconds after a capture. In case you happen to get the condition wrong and it triggers always, well, it will not be doing a capture every minute for that. And finally, a very good option is the --no-stalk. And what this does is it triggers the data capture right away, and it only runs once. This is very useful if you have an emergency situation, and we use it a lot. Also, support engineers and customers. I've instructed my customers to use this if I'm not around, because even a phone call, a consultant can be online in just a few minutes, but maybe a peak in traffic can take like 30 seconds. And so if you don't have anybody around who can help you diagnose a problem, at least if you have this script installed, you can run it with no-stalk, and it will save the capture. The captures include a lot of things. Most importantly, for example, InnoDB status, show process list, the output from show global status, the MySQL error log, df, free space from that, and top, the running processes, a lot of information both from MySQL and from the host OS. And so, if you may not be ready to diagnose, or maybe you don't understand fully what's going on, at least you will get a lot of information that somebody else can take a look at and help you diagnose an issue. And it's a lot of information, and because of that, we're breeding pt-sift. This helps you basically sift through all those captures and give you a high-level overview of them. You sometimes end up digging into detail by manually opening an individual file, but a lot of the times I've found the solution to a problem, the root cause to a problem, just by looking at the output from pt-sift. And here's an example. It makes a summary of the disk activity, vmstat, InnoDB, which may or may not be important to you if you're using that engine, process list, and then if you used it, stack traces and profiles. It's important to note that by default, pt-stalk is as safe as it gets for troubleshooting. It doesn't run anything that is known to be obtrusive, so you can run it safely. It does, however, support some more intrusive data collection tools if your program so requires. So for example, you can enable captures of GDB stack traces, you can enable use of strace, you can enable use of TCP dump, you can enable use of oprofile. So again, that's all disabled by default because, for example, both strace and GDB are known to, in some weird cases, but not so weird that I have not seen them myself, make a server crash or end up inconsistent after attaching and detaching. But if, for example, if my advice to customers and what I do myself is typically if the server is already host, like you're getting no response at all from MySQL, your next step is going to be to power cycle the server, or at least restart kill-9 MySQL D. Well, then go ahead and do a stack trace, because maybe it's stuck somewhere and if you want to escalate this or report a bug upstream, the developers are going to want to see a stack trace. Otherwise, they'll be just making wild guesses. In this case, the parts that I've highlighted are part of the InnoDB summary, and it sets at which threads are waiting. This is all obtained from the output of show InnoDB status. Be advised that if you have a lot of work on a server, InnoDB status will be truncated, and in that case, this information will be, skewed. It may lead you to believe something that is not correct. So by all means, in that case, pt-sif prints a warning. It can get lost in all the black and white text, but do look for it. It says something about InnoDB status was truncated, and you can also realize by looking at the actual InnoDB status file too. In this case, this is not what happened. We have a normal capture, and you can see that we have, about 220 threads waiting on certain lines. And if I went there, look at the source code, and they are all waiting for the kernel mutex. This is a known problem with MySQL 5.1. Well, it's still a problem, but it has improved a lot. But in 5.1, under high concurrency log, the kernel mutex was a very well-known bottleneck. And here's a good piece of evidence about it. And in this case, I don't even have to go to the actual capture files. pt-sif was enough to solve the problem. And well, that finishes the review of the tools. The message that I would like you to walk home with is, first, don't reinvent the wheel. I mean, we've put a lot of effort and testing in developing these tools. They evolved and developed after, somebody in the real world had a problem and we had to solve it. So it's not like, it's some dream or some, scratching an itch. No, not like that. It's a real problem that we had to solve, and we thought that writing a script to help us solve it was the best way to do it. And we've been burned, so you don't have to. For example, fill in the disk, killing MySQL, a lot of things, edge cases that, if you may be a very big setup, having a lot of servers, but, maybe some edge cases escape you. And we've seen pretty much anything there's to see out there, and whenever we've been burned by something, we just incorporate that knowledge into the tools to help us and avoid that in the future. So that's why I would recommend doing that. Well, I thank you all for attending. We have a few minutes now for questions if Sarah will wait to me, and I hope you have enjoyed the webinar and have gotten good value out of it.
Okay, thank you, Fernando. Again, just to remind everyone, if you have questions, please enter them in the questions window in the GoToWebinar control screen. First question we have is, are there Zabbix plugins for monitoring? Fernando?
Oh, hi. Yeah, I lost your audio, sorry. I don't know why.
Okay. Can you hear me now?
Yeah.
Okay. First question, are there Zabbix plugins for monitoring?
No.
No. Okay. Next question, when renaming the tables takes a long time, what about the transactions in the meanwhile if the table is especially large?
Yeah, that's a good question. Actually, I'd like to follow up that one on a blog after doing some tests. I have used it a lot in production, but always in the 2 or 3 customer cases that I had to use it myself, they were all using auto commit on one. So any transaction was as large as the longest running statement. So I have not used the tool with multi-statement large transactions. I will have to test that.
Okay. Next question. In the case of a slave behind master, can you explain how to run pt-table-checksum and pt-table-sync from the slave?
No, you would always have to run it from the master. One thing that I did not explain, and so I'm glad this question was asked, is due to the fact that pt-table-checksum uses MySQL's built-in replication to propagate its queries. It is the only known way to have, do a consistent checksum. So, for example, if you were to checksum the actual data, which I have seen some people do, go to the file system and checksum the MyISO files, the InnoDB table spaces, you have changes going on 2 sites or on whatever slaves you have. and there's no way to make sure that you have a right moment in time. So pt-table-checksum uses replication to its favor, and both tools should always be run from the master. The only time that you can run pt-table-checksum on a slave is if you just want to run it to verify the results. So for example, if you use --replicate, as I used in the examples, then you have an option that is called --replicate-check-only, and this connects to a slave, reads the checksum table, and if it found any differences, it shows the standard output, but it's just a checking tool. Otherwise, both are always run against masters.
Okay. Next question. How many of these tools work reliably on Percona Server 5.0?
I actually checked that with the development team, and all of them are supported. All of them are supported on 5.0. There may be some edge cases, and I'm not aware because I have not worked with 5.0 for more than a year now. I've been working in specific cases in which I've been doing a lot of 5.5. But I checked with the main developer a couple of days ago, and the biggest gotchas are actually for 4.1. For 4.1, most of them are not really supported. They do work, but they don't have test cases out of that. pt-accuracy is pretty good tested. But for 5.0, we have a good test case, and even though you may come up with an edge case, I think it's pretty much reliable.
Okay. Next question concerns pt-table sync, and the concern they have is around synchronization load time. So the question is there a way to display the size of the data discrepancy in bytes, or determine a threshold after which this tool should not be used in favor of a manual synchronization?
Not in bytes that I can think of automatically, but you can do some basic queries and try to estimate that. Basically, the checksum tools will write to that checksum table the table and chunks. The chunks are specified by the boundaries, which is basically a condition to aware. So for example, if there is a data difference in ID 7 of the table employees, maybe the chunk says something like, employees were ID between 1 and 1,000. And so what you can do is run pt-table sync with --print, and it will just write the queries to send that output, and then you can get an idea. But otherwise, no. And I will take the opportunity to also say that unlike pt-table-checksum, pt-table sync does not support any way of throttling. So if that is also a concern, which in some cases it is, what I have done in the past is just use --print instead of execute, send it to a big file, then chunk the file and manually run the changes.
Okay. Next question. Does the online schema change work for fast index drops and creates?
I think I've had, I would say I have to check, but my initial reaction will be probably not yet. But not just the online schema change. I've had other problems with the online index creation and this kind of tricks. So just please write it down for me to follow up on the blog. But initially, I would say at least don't try it unless you actually tested it.
Okay. Next question. Does pt-table-checksum tool work with databases greater than 1 terabyte?
Yeah, it's okay. Due to the fact that it does chunking, I think the biggest data set size I have used was close to 2 terabytes on several tables, but there were individual tables that were around 800 gigabytes or so. And since the tool does checksum in terms of chunking, it really doesn't make a lot of difference. It takes longer, obviously, but other than that, no major impact in the load or anything like that.
Okay, very good. That's all the time we have for questions right now. Just to wrap up here with Fernando's last slide, the speaker schedule was announced today for the Percona Live MySQL Conference and Expo, which is in April in Santa Clara. Please check it out at the conference website, and if you're interested in going, please register soon. Super Saver discounts are available through January 20th. That's all for today. Thanks for coming. Fernando, thank you for your presentation.
Thank you, Terry. Thanks, everyone, for coming, and I'll follow up with the blog post. And remember my email from the first slide. The slide deck, as Terry said, will be published. Just don't hesitate to contact me directly if you have any questions.
Okay. Thanks, everyone, and have a good day.